Hey there, just wanted to show you the progress on my VX motor rebuild. I've got a couple of these engines, and I bought these skis pretty cheap. They had ingested some salt water and sat for a couple of years. Top end is pretty bad. I'm gonna go ahead and get new rebuilt heads for them, but the bottom ends actually looked pretty good. From the outside, you can see there's some salt corrosion, etc. I pulled the case halves apart, pulled the crank out. One of the things that encouraged me about this motor or both these motors really, is when I pulled the oil, drained the oil out of them. The oil was actually in really good shape. Now there's some sludge in the bottom of this guy that looks like it's a little milky, but the oil actually came out really black, and that's a great sign for a motor. Even though this motor was locked up and would not turn, I knew that the oil coming out clean was a great sign. So what I did is I pulled the case halves apart. You can follow a shop manual as to how to do that. The cylinders were in pretty bad shape. I actually had to tap out the pistons. And then what I did, one of the things about these, and ignore the salt corrosion on the outside. I'll take a walnut shell blaster, and I'll should be able to get most of that off. But one of the things about these VX motors is that the cylinders are Nickel coated, so they're coated with just a few thousandths inch thick of very hard substance called Nickel. It's brand. It's actually a trademark name, Nickel. What that means is that the piston rings and the steel piston rings and the aluminum piston rings themselves are never going to wear down the cylinder. They will never wear it down. Now, they could score it. They could, if something breaks and hits it at 8,000 RPM, certainly could take a chunk out. But in a normal operation, these cylinder walls will not wear. Okay, they will not wear out. So what you can see here is what I've done. I wish I should have taken a video of what the walls looked like before. They look terrible. I took my flex hone, which is it's an AO. This is a 320 grit AO. I don't know if you can see that there. It's kind of there we go. And the AO is safe for Nickel. And so what I do is you take the drill, you put a little. There's some flex hone oil. I typically always use motor oil, and I flex hone the cylinder. So in and out, in and out. There's a technique that you use, and I'll have to show you another video of that, for about 45 seconds to a minute. And ultimately what happens is it cleans up all the glazing that's on the cylinders. You can see there's still a little bit, but one of the great things is you run your finger over even this little piece here. When you run your finger over it, I mean it's completely smooth, really good shape. All four of them really good. You've got good cross hatching now on there from the hone. And what I'll do too, before I go through the trouble of cleaning this up further, I'll go ahead and mic it out according to the book. I'll measure the width of the cylinders themselves at the top, bottom, and center with a mic, and just make sure it matches up with intolerance. But I've done this before quite a few times. I know it's going to match up. So especially again with that thin film of Nickel that's coated on there. So I think we're good with the top part of the bottom end, if you will. If we look at the bottom here, what I've done too is I will replace the bearings. Now, I didn't rely on the colors of the bearings here. What I did first, and this is what I always do, is I'll look at, again, you've got to get the shop manual. I'll look at the numbers that are stamped on the side here, okay? And then you match them up with what's on the webbing of the crank, okay? And according to the book, you can tell which bearing actually belongs in each of these. And once again, I will mic out this crank to make sure that it's within tolerance, but again, doing this many times and looking at it, I can tell you right now it's going to be fine. So there was looks like tiny bit of salt water that got in here. You can kind of see one of the oil holes is slightly plugged up here. I'll clean all that up. and I think we'll be good to go. Now, the last kind of issue here is around the pistons themselves. The rods are good, and I will definitely replace the rod bearings. Again, just I don't mind replacing or spending what I need to spend to rebuild the motor, but I'm not going to replace anything if I know it's good. Okay, so one of the things is with the rods here, what I've got them, they had very heavy varnish on them. So what I've got is this Chem Dip, Berryman Chem Dip, which works great for taking the varnish off of the rods themselves. So let me show you. I soaked a couple of these earlier, and then I just dropped them all in again. But let me take a look. Let's take a look at one of these rods and see this, or excuse me, one of the pistons. So you can see the piston is really starting to get cleaned up here. The varnish is starting to come off. The big thing is getting that varnish off and then getting the rings out, because the rings are stuck inside of the the piston grooves. That's a little bit more of a challenge too. So what? I'll probably try to make another video of that. These are very, this is a small motor. Grooves are very thin with those rings stuck in. I know I can clean the pistons up, but the pistons aren't going to be any good unless I can get the rings off, which are stuck in there. So what I'll do is once I get the pistons cleaned up, I'm going to leave them soaking in here actually overnight. Once I get the pistons cleaned up, if the rings are not able to come off at this point, what I'll do is I'll use some heat, some propane heat, and heat them up and see if I can loosen up the rings slightly and then be able to pull them off. So ultimately, the ideal thing, and this is probably not a worst case motor, but it's not a great case, but it is definitely a rebuildable motor. Worst comes to worst, I'll have to buy new pistons, but ideally I would love to use these existing pistons. It's all OEM rods and pistons. Would love to use these existing pistons, but just obviously I'm going to replace the rings. I'm going to replace the bearings on this. I will also get new. The rod bolts are stretch bolts. Okay, so you do have to buy new rod bolts. There are no aftermarket rod bolts. You have to buy OEM. About $80 for a set of 8. So I will definitely do new rod bolts. But really, for about $300, I'm going to be able to rebuild the bottom end of this VX motor. So one additional thing here is the VX reduction gear drive, which is here. You want to be sure that this bearing, which the crankshaft goes into right here, right, and then this gear, which actually drives this 1.47 reduction gear. Sorry, this is actually straight through to the PTO. So when we turn this reduction gear, you'll see it'll actually turn the PTO there. Very smooth, very smooth on the oil pump here. No reason to believe there's any issues with this bottom end. So I'm likely not going to do a whole lot down here. Thanks for watching.